live. So yeah, there's a thumbs up. I'll take a thumbs up. Thank you. So good afternoon, everyone, and thank you for joining us. Can everyone hear me okay? Okay. My name is Christopher Gallick, and I'm an associate professor here at NC State in the Department of Public Administration, also part of a faculty cluster doing energy systems and policy work here on campus. I'd like to welcome you to the first day of Energy Week here on campus, and also our panel on extreme weather and the grid. When we think about electricity and reliability, the first thing that comes to my mind is generally how reliable the system is. When I walk over to a light switch, the vast, vast majority of the time when I flick that switch, the light comes on. When we look at the broader grid, just last month, and I have my stats here so I don't screw them up here, the North American Electric Reliability Corporation, or NERC, reported that the US bulk power system reported that no operator-initiated loss occurred for 99.74% of time in 2020. Of what little losses did occur, it was 0.0003% of total energy served. So on the surface, those seem like pretty impressive metrics. But one thing to pay attention to is those losses that were reported are more than the last 4 years combined. On top of that, we can all relate to experiences where the grid is not performed as reliably as I mentioned when you walk up to the switch and flick it. I remember well an ice storm that hit here when I was in grad school that knocked power out for days. More recently, we saw the extreme disruption that extreme winter weather event had in Texas, the destruction associated with wildfire in California, and the devastation associated with hurricanes Ida in New Orleans, Matthew, Florence, and others here in North Carolina. Climate-induced or climate-enhanced natural weather disturbances are not going away, so the question then becomes, what should we do before, during, and after they occur? I don't have answers to those questions, but thankfully we have 4 tremendous speakers that I hope can shine a light on some of those important and enduring questions. I'd like this to be a conversation and not have to have you listen to me yabbering on all the time. So what I'd like to do is introduce our 4 outstanding speakers today, and then proceed right to a prompt, an initial prompt, and then just let the conversation go from there. If there's questions online, if there's questions from you, I'd love to have those as well. Again, have a conversation here. We asked that the podium be slid across, so it's less of a presentation too, but more of a conversation among. So, with that being said, I'll get on with my shutting up here and introduce the panelists. So immediately to my left, we have Ms. Rebecca Ward, Assistant State Climatologist with the North Carolina State Climate Office. Next, we have Dr. Jordan Kern, Assistant Professor, Department of Forestry and Environmental Resources. Next, we have Mr. Tommy Williamson, Engineer with the North Carolina Utilities Commission, Public Staff's Electric Division. And last but certainly not least, Mr. Robert Beadle, Director of Grid Infrastructure from North Carolina's Electric Cooperatives. So Rebecca, my first question, and that's to you, and then same for the rest of the panel, is from your unique perspective, and we have lots of perspectives here, both disciplinary as well as professional and experience. What is the thing that is foremost in your mind when we talk about extreme weather and the grid?
Yeah, so my background is in climate, so that's really where I'm coming at this from. Kind of like the things you mentioned, how is our climate and climate change really enhancing a lot of the extreme weather we're experiencing? It kind of feels like whiplash sometimes if you're watching the news between wildfires and then hurricanes and then ice storms, trying to keep track of these big events. The thing that's really been on my mind lately are the ones that are a little more subtle and may not get that big attention, but are still extreme weather driven. And so by that I mean when the power is knocked out by an extreme weather event and then we have a period without power, how is extreme weather compounding the impacts of not having electricity during that time? So for example, recently with Hurricane Ida, we had electricity generation that was knocked out, and people in Louisiana were without power, which is pretty typical. I've been through hurricanes and it's not pleasant to be without power for a few days. But when that's compounded with an extreme heat wave, that can really exacerbate some of those impacts. How do you stay cool? How do you prevent your food from spoiling? If you're on well water, how do you get drinking water? Well, you might have to go wait in line for a while to get that. So that's really where my mind is going.
Jordan?
Yeah, so my perspective is both that of, I guess, sort of a systems engineer and a modeler, but also somebody that thinks a lot about finance and economics. And so what my group at NC State does is we develop software that simulates the way the grid operates more or less in real time. And then we perform stress tests. So we try to sort of see what types of extreme weather conditions break the grid. And reliability is certainly a public safety issue and also an economic issue. But we also monitor the way the grid operates, not necessarily in a place like North Carolina, but in much of the rest of the United States, as a wholesale market for electricity, and how extreme weather creates shocks in both supply and demand. So if you think about, and I don't know what your exposure to microeconomics is, supply and demand are interacting to create prices that go up and down. And the grid you can think about as two sort of forces of supply and demand that have to be in balance all the time. Demand would be driven by extreme weather in the form of very, very hot temperatures and very, very cold temperatures, which would increase electricity demand. And supply can be variable too. The more we decarbonize the grid, essentially the more we're relying on sources of energy like wind and solar that fluctuate, that might be really high one day or 1 hour and low another period of the time. And out west, increasingly what we're hearing about throughout this year is drought, which essentially takes away a major source of zero carbon and low cost generation from the western grid, which is hydropower. And all of that put together can make prices do really crazy things, and we saw that in California last summer when there was a blackout. Prices increased by a factor of 100, and it was even worse in Texas in February. And Texas has a slightly different way of running their market, but prices went up to as high as $10,000 per megawatt hour, which is almost 100 times normal. So that's sort of the perspective I bring, is the grid as a marketplace.
So I'm with the public staff, and does anybody here raise their hand if you know who the public staff is? Ever heard of it? That's exactly what I thought. Okay. So just a little bit about who we are. So, and I think about the grid long term as well. So think about the grid that we are enjoying and benefiting from today actually got its start in the late 1800s. And it's been growing in size and complexity up until what we have today. And in 1977, the North Carolina General Assembly created the public staff. And our role is to act on behalf of the using and consuming public in all matters involving an investor-owned utility like the Dominion and the Dukes that come before the commission. So our role is to look at the operations and the plans that those companies propose, and we're looking at the affordability of those plans as it relates to their obligation to serve the customers in their service territory. And some of those plans can be requests to increase rates in a rate case. It can be the IRP, the Integrated Resource Plan, avoided cost proceedings. So that's sort of a high-level view of what we do. Included in that are proposals by the companies to change the way they're operating. You mentioned all the variable sources of generation, and you're right, as we have built a grid over 100 years that has been pretty much built to transmit energy from a generator over transmission lines to consumers in a distribution network, there's a lot of turmoil going on in each one of those areas, from generation, using variable sources, to how transmission lines work, what's happening on the local distribution grid. And I'm actually working on Duke's ISOP, which is the Integrated Systems Operations Plan, and that's going to be about a 2 or 3 year look at how we holistically look at what's happening in the grid now and all the possible changes and adaptations that are coming based on weather events and other pressures. So I'll leave it at that.
All right, thanks. And I'm Bob Beadle. Just to give you an idea of the electric co-ops in North Carolina as well, we're in 93 of the 100 counties in North Carolina. We don't serve the urban areas, but we do serve a lot of rural and coastal areas. And we have about 1 million members on the system across the state. There are 26 electric co-ops. And echoing on some of the same themes you already heard, there's already a lot of attention at some of the resilience and being able to build that into the systems. A lot of our coastal co-ops have gone to concrete poles and bigger conductors with the idea of being able to withstand windstorms a lot better. There's things that we look at in terms of contingency planning and how we're able to backfeed. In other words, you have a normal utility source. If that's out, can you redirect power from other directions or other resources to still keep the lights on? So there's a lot of that discussion that goes on as well. And then also we have mobile substations and other tools at our disposal to try to keep reliability as high as we can. It's also a big challenge for the industry because previously people sort of looked at a peak load case, and as long as you had enough generation to match the load at peak conditions, you were fine. You knew that everything was going to be okay. Well, things are changing quite a bit, and a lot of your system constraints may not be at a peak time. You may need to look at solar integration or other things that are off-peak and make sure the system is still okay for those events as well.
Thank you. So one thing before I open up for questions, I just want to respond to something that I heard here, and that's how incredibly technical the system is in terms of markets, in terms of technology. But I think at the same time, there's also this very visceral question that at least is in my mind of when we see something like occurred in New Orleans or in Texas or in California, what do you think, I'm not putting you on the spot so much here, but hypothetically, is it possible for something like that to happen here in North Carolina? What do you see as the potential for something like that? And what do those types of events say about the resilience of the grid overall? And I'll just put that out there.
I'll just jump in and say, I can't really speak to the grid part, but to the weather part, we absolutely experience those same type of events. We get hurricanes, we get ice storms, we do get wildfires, maybe not to the same size as you see in California, but in 2016, we had simultaneous Hurricane Matthew recovering from flooding in the eastern part of the state and a severe drought and intense wildfires in the western part of the state. So experiencing those types of climate impacts is absolutely something that we have and will experience in the future.
I'll go ahead and speak to the
Go right
grid.
ahead.
A lot of your planning needs to take place in a day like today, not 2 days before an extreme event happens. So you have to kind of start taking a look at things. Using flooding as an example, you can raise a lot of your control systems up in the air because that's going to be kind of your pinch point. Those are going to take a long time to replace versus something that's a lot easier, fencing or something that's not as critical to that electricity reliability that you're used to. So it's important to take a look at that as well as everything else in terms of your contingency planning. And as far as Texas is concerned, one of the big issues there is they had made a decision reacting to market prices not to winterize the plants. In our case, the polar vortex was kind of a big wake-up call for us. We put a lot of winterization in, and it's important to take a look at that. Are there things that you can do that don't cost a lot of money or time to do? There's heat tape. You can go through and look at your auxiliary systems and decide we can keep reliability up with a relatively low level of effort, or can we? And it's important to gather all that together before an event happens.
Well, and to follow on that, the Texas was an incredible event this year to have that much of a deep cold go down in there into that part of Texas. And part of the technical part of it is, you're right, you've got to balance load and supply at the same time. And if you don't, you get problems. You get problems with your voltage and your system frequency. Matter of fact, they said on February 14th, they were 4 minutes away from system collapse in Texas. Now think about that. You got an energy state like Texas, and because, like you said, they had not done some weatherization to prepare for cold events, they had generators that could not turn, meaning a lot of wind and coal and some gas. There were some problems there. But NERC applied to FERC back in, I think, June, and they just came out, I think, a month ago with cold weather reliability standards. So hopefully going forward, at least that'll be taken off the table. But yes, we've had 2 big cold events, I think in 2015 and 18, I believe. We were in the single digits. Think about that first week of January of 18, we were below freezing for 8 days. So yes, we can have it here, and like you said, we've got to plan ahead for that.
I just had a follow-up question, so I don't know if you have an answer to this. How often, what's sort of that planning horizon looking like? Maybe flooding as an example, if you're thinking about infrastructure and building new or updating existing infrastructure, how often are you doing that? And then how what types of data are you looking at from historical floods to future floods? How does that sort of factor into that process?
Couple things there. One, it depends on the scale of what you're looking at. If you're looking at a brand new substation, one of the best sources is the USGS maps, and you can look at the floodwater maps. They're in the process of updating those, but you use what you have that's available, and you take a look at what is the 200-year flood, the 500-year flood. Let's put it over here where we think it'll be safer, and then take a hard look at, is it worth elevating some of the structures? That's sort of a multi-year planning process. But you can also look at things on a seasonal basis. If the weather forecasters are saying we're in for a really cold winter, the squirrels are really saving up all the acorns, let's revisit a lot of our cold weather strategies. Are they still appropriate for what we think is going to happen, or are there other things that we need to do?
Well, and as far as the planning, I look at two things that Duke did in recent rate cases. In their 2017 rate case, they proposed their Power Forward program for grid improvement. It was a $13 billion plan over 10 years, but the centerpiece of it was undergrounding a lot of overhead lines. That was $5 billion of the $13 billion over 13 years. And the public staff and every other intervener opposed what they were, Duke's plan. Not only that, but also the accounting treatment of how they were going to recover from ratepayers. None of us opposed undergrounding, but to use that amount of undergrounding over the short period of time, we believe, because that was right after Hurricane Matthew. Matthew was in October of 16. In May of 17, Duke did Power Forward, and like, whoa, your number one piece is undergrounding of about 10,000 miles of lines. And Duke has about a third of their lines underground, 2/3 overhead, out of about 100,000 distribution miles. So that was a pretty good chunk. We oppose that, but then we go forward, and because of the flooding that we'd experienced in Michael and Hurricane Florence, Duke identified about 8 substations that were getting flooded. And they took some mitigation steps. I think they relocated 2, and then they put walls around the other 6. And so we definitely supported that. Those were steps to take based on actual performance. And so that's out of in the mid-hundreds of substations that Duke owns. They identified 8 that needed some mitigation. So I think that's where it goes back as far as our review of the affordability. Let's take steps that are concrete, and then let's keep undergrounding lines as we identify specific circuits that would benefit from it. So.
Mm-hmm. I have a boatload of questions here that I can ask all day. Are there any questions in the audience before I kind of jump back into it? Okay, so Jordan, in the meantime, you mentioned in your introduction a lot of interconnectedness when you're talking about the markets. We saw in New Orleans recently how flood protection infrastructure generally held, but the electricity infrastructure generally failed. How does the interconnected nature of our various infrastructure make society more or less vulnerable to extreme weather?
Well, I think you can go either way on that, right? I think when you talk about the interdependence of multiple sectors, that makes us more risk prone, I would say, right? So one of the main strategies that has been put forward to decarbonize the economy is to essentially electrify everything. And the foundation of that would be having a grid that is close to zero carbon, powered mostly by wind and solar or nuclear or other types of low carbon resources. And then you could electrify transportation, industry, heating, et cetera, right? So the quickest, potentially cheapest way to decarbonize the economy. But then you have all your eggs in one basket, essentially, which is the grid. And if there are then grid failures, that represents a larger, wider systemic risk. And that certainly happened in Texas in the wintertime. Loss of electricity was one of the reasons why their water distribution systems failed. So on top of having people exposed to really cold temperatures, they lost potable water. Texas is also another example of how interconnectedness is a strength potentially. So one of the reasons that Texas was so vulnerable is they're sort of an island electrically. The US grid is separated into three major interconnections: the eastern interconnection, the western, and then Texas. And so one of the reasons why North Carolina may be in some ways better suited to go through extreme events is because in a pinch, we could try to buy electricity from our neighbors. Now that's presuming that they're not also experiencing, sub 10-degree temperatures as well, and that's an issue we'd have to look at. But there's a lot of reasons why being part of a large interconnected grid might make systems and different system operators more reliable in the future, especially if they can coordinate operations to do some sort of spatial hedging.
Thank you. Yes? So if I could just repeat the question for those that may not have heard. The question was, and correct me if I mis-summarize here, if that's a word, mis-summarize. I'm sure it is. Have somebody check my own restatement, my own statements. Whether to go slowly into sort of a decarbonization so that we're watching resilience as we go, or preparedness, I should say, for extreme weather, or rush into it and then sort of backfill after it's already out there. Did I capture that correctly? Okay.
That is a societal choice that we're faced with. And I think, I think from the public staff and the utility commission's perspective, it's a cost issue you have to be mindful of. I don't want to put, I'll let you speak,
Sure.
but to me, it's are people willing to pay to go full speed ahead or not?
And part of it, I think, all the above needs to be more of an answer. In the past, we made a great deal of progress because there were a lot of old coal plants that probably needed to be shut down anyway. There were a lot of upgrades that would have been needed to them, didn't make any sense to continue them. But going forward, you have to make some decisions about things. If you have a whole bunch of your generation dependent on offshore wind, what do you do if a Cat 5 hurricane comes up the Atlantic? Those windmills are sitting there. Do you take them down? What are the practical decisions that you'd make around that? How do you replace that power? So it's things like that that you need to dive in and think about contingency planning and how to. But that said, there's things like microgrids, batteries are really coming along. A lot of the technology isn't quite there yet, so I think we need to be very careful not to let the policy get ahead of all the market availability. But I think all the above is probably a better path forward.
Well, if I could just touch on something you said, if you could expand a little bit on what you mean by microgrids. I'm not sure that's something that everyone might understand.
There's a lot of different forms, but the idea is microgrids can be something where, let's say you have a neighborhood of houses and you lose a normal utility feed, there's a way for batteries and maybe some solar or other resources to switch back in and pick everything up. So we've had a few residential microgrids lately that have come online that the battery is there, but the battery only has a few hours of electricity available. Typically, it's best to pair it with something else. Some of them have, say, a propane generator that's a little cleaner, or some solar that can help back it up in case of one at the coast. But there's other considerations with that as well. Solar, typically in the wintertime, your peak is about 7 a.m. on a January morning, not a whole lot of solar available. So that's where maybe you could back it up with some batteries, harvest the solar the day before because it's typically a very clear day leading into a clear night that gets very cold, and then the batteries are available during the peak hour. So you've got to look at a lot of different resources to make that happen and not be completely dependent on one thing, but eventually sort of move toward cleaner sources of energy.
And I think what you said there, as far as eventually we will move there. Like I said, we started in the late 1800s on building this grid and getting where we are. So We benefit and we enjoy it. Now, let me ask a question. As far, we measure reliability and resilience differently. Reliability is how well does the utility keep the lights on? So, there's 8,760 hours in a year. So let me ask a question. Raise your hands if you would be happy at your home being out of power 24 hours out of that year. Summed up, 24 hours. Nope. Oh, some? Okay. Who would be happy? Let's half that. 12 hours. Who would be happy with 12 hours a year out of power? Some? Let's half that. 6 hours. Who would be happy with 6 hours utility could not give you energy? Okay. Well, over the last 15 years, if you take the average from Dominion and the Dukes, it's about 2.5 hours. So that's, and there's been fluctuations up and down, but that's a pretty high level of reliability. So the question we have to ask is, well, what is your risk? Are you willing to take, and a lot of hands went up at 3 hours, and that's great. And a lot of you went up before that, so you're happy with that. You're willing to take that. That's the risk you're willing to bear. And Duke, in their last rate case, said most non-residential customers have already priced in those outages, and they're not willing to pay significantly more to prevent them. So they've owned that risk. And think about a data center. Data center pretty much wants 100% uptime. They have spent a massive amount of money in generators, multiple utility feeds, batteries, UPS systems. That data center, from whoever it is not going down. But they've owned that piece of the reliability that's not present. Now, the issue too now with resilience is we can say, another question, if I had a storm and 1 million people were disconnected, 1 million outages, and the company got everybody back in 7 days, is that good? Would you think that was good? 7 days restoration of 1 million customers? A couple of hands? What if I had 2 million outages and it took 3 weeks? Is that good? Answer is we don't know. Those are both real numbers. One is from Matthew in 2016. The other one is the ice storm in 2002. That was massive. The whole state was affected by it. 90 counties had a trace of freezing rain. If you drove from Gaston County to Lake Gaston on I-85, you were always in a county that got at least a ½ inch of freezing rain accumulation. Durham was the gold medal there. 1 inch of snow, ½ inch of sleet, and 1 inch of freezing rain. Durham was devastated. And it took about 3 weeks for them to get a lot of overhead lines in Durham. It took them that long to get back. But we don't know if that was good or not because there are so many variables to measure the impact of a storm. What were the conditions before the storm? Was it winter? Were there leaves on the trees? Did we get saturated with rain? Were we in a drought? That's always going to affect the impact of the storm. How heavily populated was the area? You can take what happened with Florence and Matthew, affecting sort of the same area from, say, Calabash to Wilmington, and very populated today. Y'all got a microgrid down there. But then you get back 30 years to Hurricane Diana, and it kind of hit the same area, dumped about 1 foot of rain. How do we measure that impact? But then you go back 30 years to that, to the decade that had the most activity, storm activity, and that's the 1950s. Anybody ever heard of Hurricane Hazel? If you haven't, your parents have. Hurricane Hazel, the only Category 4 hurricane that landfall in North Carolina, hit with hurricane force winds, 18-foot storm surge. That's higher than this curtain. It was moving 30 to 55 miles an hour. It took 12 hours to get up into Pennsylvania. This thing was cranking. They said, National Weather Service said every sign of civilization from Calabash to Wilmington had been annihilated. That was in 1954. What if Hazel had hit today? Your microgrid would probably have been up here in Raleigh. So we don't know how to measure resilience right now to say, is recovery good? So to shorten get back to your point real quick. As we make these changes to respond, to have resilience, we do look at affordability because we could go full speed today and change everything, and no one would be able to afford that system. So we have to have the ability for ratepayers to pay for the energy that they are being delivered. So I think it is an all-in approach. I think it's going to be probably more incremental. We've got to get there over time. Thank you.
Thank you for that comment, and it reminded me, I was here in Durham during 2002, pulled a pine branch about yay big out of my neighbor's roof. First time I ever had any roofing experience. I did a very poor job. we were without power for 2 weeks. And it was not warm during that
It
time
wasn't,
too.
sorry.
So that was, I went to sleep that night and you could hear the lines popping. You could see through the blinds. I had cheap apartment, cheap blinds. You could see the sparks in the sky. It was surreal. So I can definitely relate to that. I want to come back to something, and this was brought up on the YouTube chat, talking about undergrounding and whether that's something that is going to be coming back. And I want to kind of tie that into a larger conversation about affordability, because that keeps coming up. But also this interesting dynamic that we're talking about a for-profit company in Duke. And you have in this, you have a critical service being provided by a for-profit company in which you have multiple regulators and regulatory bodies, the one you represent, obviously, very interesting role that it plays. So how does a for-profit utility enter into this conversation of extreme weather in the grid? Who provides leadership? What are the checks on that system? And how does that differ than, say, like a co-op in the model that they have?
Well, I'll go first. So you're right, Duke is a for-profit company, but understand they are a regulated monopoly. So everybody, when they come into for a rate application to increase rates, the commission ultimately will approve an approved rate of return. That says they can earn, they are eligible to earn up to that. It's not a guarantee that they will earn that. So they still have to manage their business. They still have to serve customers. They're in the business of providing energy, so then that energy can be paid for. So, and that all affects their rate of return. So they do, I forgot the second part of your question. Why don't you go? I'm going to come back.
Oh, all right, okay. So as far as electric co-ops, they are also regulated, but they're regulated by the Rural Utilities Service, which is a part of the USDA, so it's part of the federal government. They have a board of directors that's made up of members that oversee decisions that are made by the co-ops. And interestingly enough, we're about 94% residential, so one thing that comes up a lot is undergrounding at the distribution level. There's a lot of newer neighborhoods and cities that have mandated that basically as a part of new construction. So a lot of neighborhoods now put the electricity underground already in various areas. So a lot of the distribution is starting to go underground. Cost isn't as much of an issue there because it's about 2 to 3 times. It's when you get to the transmission that we're talking about, bulk transmission, that can be 5 to 7 times the cost to put it underground. So that really has to be a big discussion of, is it worth it? Are you going to see some benefits from doing that, just given that level of cost and impact?
Thank you. It was targeted underground. That's where I missed that part. So the ice storm that you experienced, okay, the commission came out, there was an uproar. I mean, think about, there was a huge swath of middle North Carolina that was devastated with at least a ½ inch of ice. So they said, wait a minute, what can we do to avoid this in the future? So the commission charged the public staff to investigate what would it take to underground distribution lines. So they came back about a year later with the report, and you can go on to the North Carolina Utility Commission website, and I encourage you to do that. It's a great place to find some interesting reading. I'm not saying it'll keep you awake at night, but it's some great reading. The report came back and basically said, okay, to underground the distribution lines in North Carolina will cost about $41 billion. Today's dollars would be over $60 billion. The rate impact would be over 125% increase to residential customers. The outage experience would be, an overhead outage would be, or an underground outage would be about 60% longer than on an overhead system. And so basically the public staff came in and said it was prohibitively expensive to do it at the scope that was asked for then. Duke, like I said, in Power Forward, their rate case in 2017, they wanted to do $5 billion of their $13 billion increase to do 10,000 lines. We oppose that. We don't oppose undergrounding of specific circuits, but a wholesale program like that we thought also was cost prohibitive. We believe that if there's some problem circuits that would benefit from undergrounding, then they should be converted and moved from overhead to underground. And like Bob said, there's a lot of, especially residential neighborhoods that are going that way as initial construction.
And one of the other thing I'm going to add, since we're talking about 2002, I was a brand new NC State graduate, so I got to go out with the crews, learned a few things operationally out in the field. During ice storms, trees can have the branches kind of go down, sag into the power line, then they fall down. When the ice melts off, they spring back up and can cause an outage again on the way back up. So, and you also have shorter days to work with, so that's harder on restoration as well, once your light fades and there's a limited amount of time to be able to do things. So tree trimming can be very important in the context of an ice storm as well, but provided you can't put it underground. Maybe that's at a much less cost, but it's still something that you can do going into that season. And typically, I think we see that now, if there's a big ice storm coming, you see all the tree trucks out kind of looking at the lines and doing some spot trimming.
Are there any questions? Yes.
I'm curious from the cooperative's perspective, when you've got an underground new lines in developments, do you, since you're burying, what would you bury, like a 4-inch conduit or something like that, right, to pull conductors through? Would you consider burying 2 in case you had an outage, so you could just pull a new conductor through and minimize your downtime?
What we typically do, there's usually a utility trench, so there's gas, there's electric and everything else. If they do a neighborhood, usually they'll do a loop with an opening point. So if something happens, you can isolate a section of the cable that's out and make repairs. Typically, if you're below ground, you're not as impacted by the ice storm. It stays together pretty well. We've not seen a whole lot of problems with that in the past. It's more kind of overhead and transmission.
So switching gear, oh yes. So feasibility of transition to
Nuclear.
just nuclear.
Speaking for us, we're a lot nuclear. We're probably about half nuclear. I know Duke Energy operates a lot of the power plants and a lot of the nuclear plants in the Carolinas, but we're also part owners with that. I think that's an excellent baseload capability. It needs to be part of the discussion as well. It fits in with the all the above discussion. It comes with its own challenges as well. It's a very huge capital investment, so you have to look long term. If you make that commitment, you're basically making that commitment for the next 30 or 50 years in terms of being able to match it up with other potential resources.
Yep.
But it's very reliable.
Yep. And I'd agree with that, especially, I mean, we're seeing license extended and applications to renew. Matter of fact, Wake County has Sharon Harris nuclear plant out at US 1, and I believe they're up for an extension as well. So now we're pushing 80 years on some nuclear units.
There's also a lot of redundancy built into those systems as well. A lot of people learn things after 9 Mile 2 and some of the other training areas and other events that happened, and they've made sure that not only is there contingency systems, but there's secondary and third contingency systems to operate safely.
And just to add as far as the reliability piece, because remember, one of the things that system operators have had to grow into, I believe it was 2001 when the National Engineering Foundation, they said that the North American electric grid was the most complex machine operating on the face of the planet. Because think about it, the Eastern Interconnect is everything from the Atlantic Ocean over to about the Rocky Mountains. Just that size alone is daunting. It has to operate within very tight parameters on a 60 hertz signal, okay? Not a lot of fluctuation can happen there. But as we apply more distributive energy sources that are intermittent or non-dispatchable, well, that means intermittent just means the output from it can go up or down. Think about it, the sun, the cloud goes over, it changes the output of a solar field. The wind doesn't blow, you don't get the wind, the generation from a wind turbine. The system operator has to look at that all the time. So if we drop Sharon Harris over here, a very dependable baseload plant, that's 900 megawatts, system operator has to replace that based on NERC standards within 15 minutes. He's making a lot of decisions quick. He can't go to a source that's non-dispatchable. So I can't call on a solar field or a wind farm without batteries, and there's not that many batteries that are gonna make up 900 megawatts right now. So that's the challenge that system operators have. That's part of the complexity that we have. We enjoy that. There are maybe some entanglements or things that keep us from maybe going faster toward the clean energy, but we keep reliability and stability within the system. I think over time we're going to get there. The pace is pretty fast, it seems like right now, but I think as technology grows, as batteries become more efficient, the price is coming down based on use cases and different chemistries within the batteries. That's going to grow, but I don't think we're there yet for a wide scale deployment, but we're going to get there.
A lot of utilities are also doing pilot projects, and we all talk to each other about a lot of this as well. So it's not just that you do all this in a vacuum. One of the things that's nice about the cooperatives is they all design their system to a common set of standards. So if we have a big storm, we can get a co-op crew from Ohio or Kentucky or even Kansas, bring them in, they'll recognize our system. They know exactly what kind of construction we have, and they'll be able to go right in with our crews. So we feel like that's a huge advantage to us when we have storms.
So I'm going to just ask a question, then I'll pivot back. But looking in, and this kind of is, I think, building on the last question here, looking into your crystal ball, what's one thing looking forward to that you're really excited about in terms of, say, positive transformation of the grid, or one thing you're really concerned about when we're talking about extreme weather and the grid? And Rebecca, I'll start with you.
I would say, so I spend a lot of my time talking about climate change, and trying to offer people solutions. What can you do? What can you do at a community level or at an individual level? And so what I really like is something you mentioned, the fact that there are now options for people. There's a lot more agency involved with, can you have a microgrid in your community? That's not something that I remember when I bought a house 6 years ago. I'd never heard that term. Wasn't even in our consciousness, I felt like. But now it's something that I'm hearing more about, and I like, to me, from the standpoint of thinking about how do we stop emitting greenhouse gases, that I could see that as one positive way to give people that agency to be involved in the process.
I can go. I guess there's sort of two things. I guess I'm optimistic about the transition towards lower carbon energy, and confused, I guess, about whether it's going to happen quickly enough, and how we define what quickly enough is. But I think the thing that worries me, and it is less to do with the grid and more about like climate change and extreme weather. I mean, a lot of what my group does is use past projections to try to estimate risk, right? So if you're making decisions about, whether to upgrade a system, and you're weighing the cost of that alongside the increase in reliability you might face, you usually do that probabilistically, right? You're trying to have some sort of distribution of, events that of different severity levels that you are worried about. And most of the time you're relying on historical data to build that distribution, right? And we know that using historical data isn't a great way to look at the probability of extreme events happening in the future if the climate is changing. And so I do worry a little bit about the integrity of our ability to recognize sort of what that probability distribution is going forward. We have lagging indicators that we can use, but those are imperfect. And I do think that kind of sets us up for occasional failures. And I hope it doesn't move too quickly and that we're able to, assess risk as we go. But that does kind of keep me up at night.
And I'm going to build on that and say I'm really encouraged by all the new projects and new technology that's out there. People are trying new combinations of chemistries. The batteries right now are really good in the 1 to 4 hour range, not so much longer term, but there's a lot of people looking at development of how do we make a 24-hour battery. And something like that would make a huge difference. But concern keeping up at night is we don't want to think of these things as just a magic cure-all. There are always going to be some trade-offs with things. One of the issues with the wind turbines, people had asked the question, well, there's wind turbines in the North Sea in Denmark and Germany. How come they don't freeze up? Well, there's a special cold weather package that's with them. So do we add that to all the wind turbines? If you have a big hailstorm, what does that do to solar panels? How do we protect them with that? The concern that I would have is what have we missed? Because we know we're going to miss something. So what is it we're not thinking about?
And I forgot to say something at the very beginning, and one is everything I say today is my own views and not that of the public staff. I always have to give that disclaimer, so that keeps my boss happy. So I think there's, as we talked about at the beginning, there's some exciting changes coming that are contemplated from every aspect of the electric system, from generation through transmission through distribution. Duke is doing a lot of self-optimizing grid that will help, that will increase reliability and have an impact on resiliency as well. My concern is that we keep the system that's affordable. You think about it, I do a lot of presentations here in Wake County, but when I do them here, I'm thinking about the people that live in Jones County, in Duplin County. This is not North Carolina. This is Wake County, and I mean that is that we got a lot of people spread across the service territories that are facing real challenges to pay for the things they need. And while, like I said, the list is endless almost to the changes we can make in the entire electric system, we have an electric system that is functioning at a pretty high level, and the changes we need to make, we have to be respectful and cognizant of those, of every ratepayer. They're going to have to pay for those, the costs that we incur from those changes. So exciting times. There's a lot of coming. You're at a great place to be joining this conversation and being part of what's coming down the road, and I look forward to it.
Thank you. Do we have one final question from the audience?
There's a couple of pieces to that. One is the permitting piece, and this affects kind of all of what we're looking at right now. If you're building transmission lines, if you're building any kind of resource, the permitting process is really long to be able to actually do something right now. We probably need to take a hard look at that. Are there things that maybe we can streamline the process or make it go a little faster? And there's also practical questions I brought up. What happens if you have a Cat 5 hurricane? Your windmills, or they call it pinwheeling, but your wind generators will basically, you can unhook kind of the generation piece of it and they can fly around. Well, above 120 miles an hour, they'll just fly apart. So at that point, if you have a whole bunch of damaged wind turbines, that's not really helping you, and that's not going to help your restoration efforts. So you've got to think through, all right, what do we do with this? Do we have a kind of equipment we can take down and do something with? How does that factor into the permitting? So great question. But the whole process, I think, probably needs to be looked at if that's kind of where we're headed.
And along with that, with the transmission aspect of it, transmission, you're looking at about a 10-year process from the time you say we need it to the time you energize it. And the challenge with distributed energy resources, if we have a lot of, instead of centralized nuclear, coal, gas plants that are very high concentration of megawatts, and I've got a couple of 50, 80, maybe 100 megawatt distributed sources around, well, they're still connected to the transmission system. So now I'm building a lot more transmission that's still taking years to go through the permitting process. And so that is another complexity and a challenge to go, how fast do we go? Yeah, we want to build these things, but there is a process to get them connected to the grid. And right now, that's not a very fast process.
And what does Ohm's law do to the grid when you tie them in? Are there new upgrades that you didn't see before that now you're going to have to do on the transmission system as well?
And that's happening today. We're building new transmission, and very shortly after, we're realizing, whoops, we need a bigger transmission line. So, yeah.
Well, the final question that I have for the panel as we approach our time here is that, as we've heard in the conversation today, there's a lot going on when we're talking about the grid. From the economics to the technology, to the history, to the ownership. I mean, there's just a lot of stuff going on here. There's also a lot of, you talked about agency. I think there's a lot of helplessness one can feel when the power does go out, especially if it's because of a severe event that is affecting more than just the lights, but homes, communities. And so for that reason, I feel like it's an interesting space to be talking about it, but there's also this removal of agency to actually do something about it. So are there things that we as members of the NC State community, as ratepayers, as citizens of the state, are there things that we can do when we're talking about reliability and resilience, when we're talking about extreme weather in the grid? Are there things that we can actually do outside of just crossing our fingers and hoping that the things we've talked about don't happen?
I'm sure I'll have follow-up thoughts on this, but the first thing I thought of is feels like the long-term kind of, you may not see the rewards today, but is thinking about being involved, thinking about those policies that are coming down the pipe, and being an informed consumer to say, does this make sense? Am I going to vote for this or not? That really does matter, especially when we're talking about a transition on the scale that we're really talking about. And maybe I'll follow up more.
Well, and one thing I would say too is get involved. I told you I made a plug for the commission website, ncuc.net. Okay, you can go there, and on anything that's before the commission, there's a docket number. You'll need to educate yourself on that and find the docket number you're concerned about. But you can put statements of position in there, and I'll tell you, we read them. We read them all. So that's a small part of at least sounding off to the commission. There are 7 people nominated by the governor and approved by the legislature. They're the ones that make the decisions about what they allow the utilities, Dominion and the Dukes, to do. So I encourage you to sound off and get involved and put your statements out there for what you believe should be done.
And I'm also going to say, keep going on the technical side as well. A lot of these utilities need people to understand the nuts and bolts of how things go together. We talked about the winterizing systems. You could have a new policy or a new mandate. We would need somebody to go through all of our existing plants, not only conventional power plants, but wind, solar, other things as well. What does it take to winterize this? Is somebody there who could tell us that you need X many people for however many days and it'll cost this much in materials? So there's a great need for that. So, and also do a shameless promotion. We do a summer intern program as well. We haven't been able to do it obviously the last couple of years with everything going on, but we'd love to have people interested in the utility business join that program as well.
Okay.
So are there any final questions? Also put in my own plug, I teach energy policy class, so that's something that can be done every other year at least at this point. Well then, if there are no further questions, if you could join me in thanking our panelists for coming by today. And this is just the start of Energy Week. We have lots more in store. Not to put you on the spot, Carla, but is there anything that we can plug for what's coming up? Oh. Yes. Fantastic. Well, thank you all. Thank you all for joining us.
All right. Excellent. All right.